Our program on performance-based fire protection codes and the design process by Mr. Michael O'Hara of Mountain Star. As I mentioned in the flyer that was sent out, that performance-based fire protection is already changing the way the building codes are designed, and Michael is going to touch on that subject and go into depth on other aspects of it. Skip the introductions. I know traditionally we have a large group, and depending on how much time we have,
go for it.
Go for it. Let's have a show of hands. Who wants to introduce themselves tonight? Raise their hand.
It's been a time-honored tradition.
We generally start the meetings with introductions.
Just do new members and guests.
New members and guests. Do we have any new members, or do we have any guests tonight?
Terry Benzie from Aon Risk Services.
David Smith, I'm working with 3M Company.
Sherry Ruby, Erickson Ellison. Julie Hagstrom, Erickson Ellison.
Okay.
Not a new guest, no, the old guest.
Tony Martino.
Michael O'Hara is a professional engineer and is president of Mountain Star, has over 19 years of fire protection experience. Michael, this is a long...
Don't read any of that.
I won't, because you could find this on the internet probably. Anybody who wishes a copy of Michael's resume may contact him after the meeting, but it's long and it's impressive, to say the least, and we're glad to have Michael here. I'm going to let Mike take it away and get out of his way here.
Thanks, Phil. How I can top that. All right. Well, I know many of you here, and a lot of you know us from the Mountain Star group, and we sort of spend a fair amount of time in this area of what we call performance-based codes. And one of the themes that I'm going to share with you tonight is that it will change the way that you will design and build structures in the future. That's a fairly bold statement, but we are seeing an evolution, almost a revolution in fire protection engineering that we've not seen before. We've got this abundance of technology that's coming together at a very rapid pace that is helping us take fire protection from the old 19th century fire mitigation strategies to a more performance-based engineering design. Not unlike, a good analogy would be structural engineering. Most structural engineering design today is done on more of a performance-based approach. And with any of this change, there's obviously going to be a lot of discord. There's going to be a lot of concerns to come up. The way I want to go through this tonight is kind of define what performance-based codes and regulations are. Talk to you a little bit about the emerging technology. And then I have an example that NFPA started to craft, part of NFPA 13D, to show you how they might actually take that and put it into an NFPA standard. What I'm about to show you is not that far off the horizon. This is happening now, whether it be an NFPA or the 3 model building codes. The Society of Fire Protection Engineers has set up a series of task forces to look at this. I'm on a couple of those. Bob James goes to some of the building code ones, and this is becoming a reality. Outside the United States, they've gone far, they're a lot further along. Australia, New Zealand, the United Kingdom, Sweden have developed some performance-based codes that are in place now. And when we go through some of these examples afterwards, you may question how they were able to do that. So either tonight will either excite you, scare you, or you may not care. You're not going to fall asleep because I've got this. Okay, well, let's talk a little bit about the codes. Really, when you look at our codes today, a lot of provisions within both the building and the fire codes are prescriptive. You know, they're going to tell you very specifically what needs to be done, whereas there's the intent of the code saying, well, what do we really mean by this? What's the intended level of safety after we've listed a whole abundance of prescriptive language? And what has happened when there is a challenge here between what the intent of the prescriptive code is, a lot of times we'll come up with alternate means. And in all the codes that we have, the fire code, building code, and NFPA standards, they have the standard alternate method caveat in there that states that this code is not intended to preclude the use of an alternate means or some other way, if you will, to skin the cat. So, but you got to prove it to us. And right now, this is probably the vehicle as an alternate means where we're seeing performance-based codes used quite frequently today. Some of the language that I'm going to use in a few minutes is actually in your building code today. It is there, and it is used in places, for example, as smoke control. But a lot of the same fire principles that we are using to quantify and approximate fire risk for smoke control systems, we can use to calculate a variety of things, such as sprinkler response times, tenability of a space, so that we can actually paint a picture on how this building may respond. So that if we had a fire in this room, we could approximate when the sprinkler had to go off. We could probably approximate how much smoke would be built up and approximate the tenability of the space. And we would do that by a variety of calculations that would take into account the inherent characteristics of this room. So we're going to talk a bit about some of those technologies that are being used to justify some of these performance-based techniques. I want to take a moment just to tell you a quick snapshot on the codes here in Minnesota, and Phil mentioned very briefly about a meeting that's coming up in Fairfax, Virginia. As you know, we're under a modified version of the 1994 edition of the Uniform Building Code. We're under a 91 edition with modifications of the Uniform Fire Code. That will be changing this year. We will be going to the 1997 editions of these codes this spring, barring catastrophe. Spring, early summer, we should probably be under one set. This will be the last set of the uniform codes that will be adopted in the state of Minnesota. What they'll be going to, and this is not a guarantee, but what we'll most likely be going to is what's called the international codes, developed by the ICC, which is consolidation of the 3 model building codes plus NFPA as it pertains to the Uniform Fire Code, or to the International Fire Code. So they're going to have a series of codes. Phil mentioned this meeting in Virginia. Well, the first draft of these codes are going to be up, particularly the Building and Fire Code. They're going to go through those for the first time, and we're going to come up with one set of national codes. So by the year 2000, that's a pretty bold statement. If you look down the time horizon, what that would mean here locally, there's a good opportunity here come the turn of the century that we may be adopting a set of these international codes. We don't know. We're not sure what they're going to finally look like, but I think that that's one probable scenario. We're seeing that they're still going to have prescriptive requirements, but they are starting to look at performance-based requirements coming into these codes. And when you look at this combination, the landscape is changing, and NFPA is taking that upon themselves with the standards making process. Within 5 years, you're not going to recognize probably a lot of things that were in your code. A lot of things in the codes and the standards will be changing. Now, there is a difference between a code and a standard for those purists out there. A code tells you when something is required, and a standard tells you where it's, how to do it. So, the building code tells you, or the fire code tells you that you need sprinklers in the building. A standard such as NFPA 13 tells you how you do it. Well, they're able to put performance-based language into both. And I'm going to use the example of both some code language and some standards language in our example. Prescriptive codes historically have been minimum requirements. Here in the state of Minnesota, the building code is known as a mini-maxi code. Basically, can't be any more restrictive. Fire code is a minimum code. It can be, the requirements in there can be upgraded, if you will, if deemed by the fire chief or the designated authority. They're generally generic by occupancy, and they establish some sort of minimum prescriptive requirements. Performance-based codes are going to take into account the entire building performance, building system. And it's going to look at how they interact together. Normally they'll exceed the minimum, and you can be very specific to each building. That is, instead of a generic approach, that is, we take a B occupancy and we have a cookie cutter set of regulations for it, you'll probably be able to customize your performance based upon the inherent characteristics of a building. The ideal situation is that maybe in the long run we'll lower cost yet improve safety. That's yet to be borne out. Performance criteria basically will define products, systems, assemblies, or areas in engineering terms. And I'm going to throw up some of these terms in a second. Performance objectives will actually have requirements for the building, the occupants. What are we trying to achieve in a quantifiable set of goals? And then what subsequent series of actions may be taken. And a lot of these things will be quantitative as opposed to qualitative. Let me give you a couple examples. In a traditional code, which is the far column here, we may have, let's say, a mercantile occupancy. We're going to call it an M occupancy. In a traditional code, we might just, it's got a generic name. In a performance-based language, we may define its fire load, or its rate of heat release. In this case, we're defining it as a rate of heat release per unit area. 50 kilowatts per square meter. Okay, that would define the fire in a building in terms of its anticipated rate of heat release, as opposed to just saying, well, it's an M occupancy. Okay, we might say something about sprinklers. Well, we're going to put in a light hazard sprinkler system in accordance with NFPA 13. We may say we want the sprinklers to be designed so they actuate when the fire is no greater than 1,000 kilowatts. Structural protection. The code might tell us, well, we need 1 or 2 hour protection per table, blah, blah, blah. Well, we might say, just demonstrate in that building that we can keep the steel temperature below 1,000 degrees Fahrenheit. With egress, the code will tell us, well, we have a certain occupant load, we need so many exits with so many feet of exit width. Here we might state, well, let's demonstrate that we can evacuate the building in so many minutes. And with the smoke management system, we used to just say, well, we just need so many air changes per hour. Now we're saying, demonstrate to us that we can prevent the smoke layer that would descend from the ceiling from a fire that's grown to keep it at least 10 feet above the floor or the means of egress. So you can see from some of this type of language, there's quite a bit of a difference in how we are going to look at fire protection engineering. Performance-based approach is essentially deciding on fire safety objectives and goals, evaluating fire ignition, growth, and development, assessing the effects from the fire, and then assessing your design alternatives. In other words, you'll do what-ifs with your design and assess to see, do they meet our fire safety goals and objectives? Now, in order to do that, you're going to have to quantify your fire life safety objectives. You're actually going to come up with probable fire scenarios in a building. Then you're going to determine the response of the occupants and potentially how the firefighters might react. Determine the response of the physical facility. That is, if we have a fairly sophisticated system, when we say the facility, how does the rated construction react? How do the sprinklers react? Fire alarm? If we have smoke control, how does it all sequence together? But we have to determine what that response is. We then want to establish expected loss outcomes. Okay, well, how bad will it be if we do alternative A versus alternative B? Then select the optimum protection design to meet those original objectives. It's pretty much the general framework of a performance-based protocol. Now, this is sort of just like showing it in a flowchart manner, but since Chris Lever's here tonight, I want to see that his design didn't look totally the way. We put your flowchart up, Chris, but essentially, you're just picking a series of fire protection designs and plotting them against these anticipated fire scenarios you've established And again, say, well, does it match against my goals and objectives? Now, I want to spend a moment on emerging technologies and then go into some examples to try to pull this down to reality. Okay. Some of the emerging technologies that I mentioned in my opening comments are because we have a greater body of knowledge now about fire physics and fire dynamics. And we've been able to put it into a useful format so that we can use it in application today. So that we can actually do the things I just talked about. Quantify fire growth and spread. Predict fire heat and smoke movement in buildings. Establish egress times and tenability. Calculate smoke generation. Determine structural steel performance. Calculate sprinkler and detector response. It's amazing what you can do when you change from a standard sprinkler head to a quick response sprinkler. You can change your whole fire profile dramatically. Test data shows it. We can now quantify it engineering-wise, so we don't always have to have a fire test. We can do some of this using hand engineering models or computer models. The computer models continue to evolve so that you can use these and apply them on different building designs, come up with approximations of how that building will react. And that will lead us then into, as one of the viable tools to help you come up with engineering justification for some of those performance-based criteria that I just showed you. I mentioned the word kilowatt before, and for some of those that aren't familiar with that terminology, it's a measure of rate of heat release, BTUs per second of kilowatts. We have wattage and light bulbs to measure of energy output. That alone will help us determine what's going to happen within a room if we know the characteristics of that room. NFPA 92B and NFPA 72 in the appendix had put together a series of curves known as T-squared fires for slow, medium, fast, ultra fast. Those are sort of prescriptive rates of heat release that have been defined. And it's basically taking you to a point of when will a fire reach a given rate of heat release. You can actually do this same analysis for specific materials. There's an ASTM test method that is there, which is basically cone calorimetry, which actually will help you take individual components, chair, furniture. We once did it for rollerblades to see how they would burn. We had to use that, by the way, to determine the commodity class, because one of the regulators thought it was a class 5 commodity, and if you've designed sprinklers for class 5 commodities, there's a big difference if you do class 5 or high hazard versus a class 4 commodity. And we were trying to determine the rate of heat release to see where it would fit in. So you can actually use that on a day-to-day basis to calculate or help you determine commodity class. But if you don't have that data, there are some defined curves that we can use, and in turn, some of those curves will help us predict how the building will react. Now, why would we want to know some of those things, okay? Well, we could calculate, take different types of sprinklers, calculate the rate of heat release, vertical axis, time along the horizontal axis, of different types of sprinklers. Here we did a mathematical computation, given a building, I forgot what the height of it was, but it's all the same height. But notice the difference, and you would know this intuitively, between the response fire size with standard sprinklers, quick response, and ESFR. Now, if we're purist with ESFR, we believe it actually will put out the fire in the spring heat release going down. However, the point being made here is that we can approximate the fire size when the sprinklers go off. One of the points I always like to look at is if I have an 85, 90-foot ceiling, I always get puzzled when I put sprinklers overhead. Gordy's going to throw something. Not the Target Center, Gordy. I'm not thinking of the Target Center. What new hockey? But it always boggles my mind when I see them up 85 feet. However, just because they're up 85 feet during a hockey game or basketball game doesn't mean Pink Floyd's going to come in and build, this huge polyurethane blocks and, stage, which they did out at the Fleet Center in Boston. Okay. But anyways, we can approximate fire sizes, and a lot of times we like to use the quick. Pardon?
How was the concert in Boston?
I don't remember. And we have the camera rolling, right, Bill? Thanks, Doug.
You're welcome.
Okay, now, what we might want to do is to evaluate that, taking that same scenario, looking at the 3 different sprinkler response times, look at the temperatures in the upper layer of that fire. And again, if we look, given same ceiling heights, that the temperatures are going to be higher when we use standard sprinklers versus quick response and possibly with the SFR. Again, what we're showing is what's already been shown in a lot of fire test data, but we don't have to go out and set up a fire test to prove it. We can approximate, and intuitively it tells us quick response sprinklers will go off faster than a standard sprinkler, and subsequently, if everything's designed right, will hit the fire before it grows to a certain size, and subsequently the temperatures will be lower. That's what this is showing. You know that intuitively. Now we have tools that can approximate this and put the temperatures in quantitative terms. You can use it with smoke exhaust. You can take this, and whether it be something like high-piled storage or even an atria, you can come up with a design basis fire for that space, approximate when the sprinklers will discharge, and design your entire smoke control system around that. Code today tells you that you can design your smoke control system, and you can assume that the fire won't grow any further when the sprinklers discharge. One of the things we know is that as we calculate the fire growth rate, we can calculate the amount of entrained air and the subsequent smoke output of a fire at a given size. So if we hit a fire, all other things being equal, the size and space being equal, if we hit that fire at a much smaller size, you're going to put out less smoke. Subsequently, you might be able to reduce your exhaust capacities. Okay? And that comes into a lot of play. If you've looked at the Uniform Fire Code, for example, then if you followed their formula, you'd have an awful lot of holes in the roof. Now, if you look at ESFR sprinklers, factory neutral says we don't want vents and draft curtains and stuff like that around our systems. It'll spoof them up. And I think I'd take it a step further, because I think some of the fire test data suggests that we might want to look at that for all types of sprinkler systems. There's a hot one. Because ventilation systems could screw up the performance in general of a sprinkler system. The jury's still out on that kind of data, but it takes this kind of technology to help us support some of this analysis. As I mentioned in that first graph, if we looked at that sprinkler analogy, that we hit it at a much smaller size, if you look at this chart, if we had a 10-foot high ceiling and we had a 5,000 BTU fire, 10,000, and the yellow is 15,000, you can see the smoke exhaust on the vertical axis. As the fire gets larger, we have more CFM that we would have to exhaust. And as just not even changing the fire sizes, but just changing the height of the building, look at the differences in the smoke exhaust capacities. Just by changing the height. And we work with architects and engineers on what's the effect of clear height. Again, we will tie this technology back to performance-based solutions, because we have to come up and say, can we protect this building in a certain manner? Well, you need, in order to justify that, a certain engineering methodology to defend that. Now, you can do that also for atria, and I won't go into that, but you can also use it with atria calculations. You can also use it to eliminate rated walls or reduce the rating on rated walls, where rated walls have to follow a prescribed time temperature curve. Well, we can show and demonstrate a very simple example of reducing the rating in a space, because if we put in a very aggressive active sprinkler system, that the temperatures would never get to the point that would require the hourly ratings as defined by code. The question is, when you put all your eggs in an active suppression basket, you have to know about reliability and how reliable is that system. That's one of the Achilles heel of performance-based fire protection. is knowing the reliability of these systems. Again, you could do the same thing with fire protection of an assembly, eliminating the spray-applied fireproofing. As I mentioned in earlier comments, if you could demonstrate you could keep the steel below its failure point, you would be able to possibly come up with an innovative system to eliminate passive protection and maybe trade it off with a very aggressive active system. Again, it comes down to system reliability. I hear the peanut gallery behind me here. Yeah, that worked well. Okay. Now, what does this mean in reality? Because these kind of innovations have been here with us for a while. I want to talk to you about how NFPA is going to approach NFPA 13D, and I think this will give you a snapshot. Okay? This is some of the language that is finding its way into some of the standards for the next code change cycle. Okay? Let's talk about, as I mentioned earlier, performance objectives. This is NFPA 13D. This is an example. This is how it's going to happen. Okay? The purpose of this document, the purpose of this standard is to provide an economical sprinkler system that will aid in the detection and control of residential fires and thus provide improved protection against injury and loss. Additionally, this standard intends to provide improved protection against property damage. Life safety shall be the primary purpose of the system, and the purpose of this standard shall include achieving widespread installation of residential sprinklers. That's their general mom and apple pie goal. Design options. You have two choices. Performance-based option. A sprinkler system designed and installed in accordance with the following sections, and I'm going to go through some of the performance-based examples. And then the prescriptive-based option. They're still going to allow you to use prescriptive codes. However, you're going to have the option. Okay? Overall performance objective. Protection of occupants. A sprinkler system shall be designed, installed, and maintained to reduce the likelihood of instantaneous or cumulative exposure to conditions that exceed certain survivability criteria by the occupants that are not intimate with the fire. Number 2, sprinkler system shall prevent flashover. This is in the standard. That's what they're going to say. Okay? System performance objective. The water supply should be reliable and capable of performing for the duration necessary to evacuate the occupants. Components, and they'll list the common components that we have for the sprinkler system. Now here's where it gets interesting. Performance criteria, survivability. This is what the sprinkler system must be designed to. The following conditions shall be attained at a distance of 5 feet above the floor level in areas where sprinklers are required. A, the temperatures do not exceed 150 degrees Fahrenheit. B, instantaneous carbon monoxide concentrations do not exceed 10,000 parts per million. C, cumulative carbon monoxide concentrations do not exceed 25% the carbon monoxide hemoglobin level. And D, the oxygen concentration is maintained at 14% or greater. Little difference than just saying, hey, I got a light hazard or something that's designed for 0.1 over 1,500 square feet or something. Okay? Those are performance objectives. Now, in order to demonstrate that you can meet those, some of that technology I just started showing you is needed to quantify that. There's no way you're going to be able to do that unless you have some engineering basis to do it. The flashover criteria. There is a clinical definition of flashover. And basically it's defined as that the upper layer temperature will not, upper layer, basically above the smoke layer that's descending, will not exceed 1,100 degrees Fahrenheit, and there won't be a radiant heat flux at the floor of 20 kilowatts per square meter. That's a clinical definition of flashover. So in order to be able to say, well, how the heck am I going to design a system to meet that? You still have a choice to go back to your standard prescriptive design, but if you wanted to do a performance-based approach, here's some guidelines. They say you have to demonstrate that you meet that criteria. And the only way you're going to be able to do that is follow some engineering methodology. That's why the codes are trying not only to put some of this performance-based language together, but we have to have reliable engineering data and calculation methods that are defendable. They'll go back in after and put in a lot of the same design criteria that you will look at. As far as fire scenarios, performance-based system, you have to address 3 types of fire scenarios in order to meet this criteria. The first one, an ordinary fire in an occupied room. And it shall be designed to be representative of free-burning fire in ordinary combustibles ignited by a small open flame source in one of the principal occupied rooms of the dwelling. The second scenario, fire with a smoldering stage type of fire. And it shall be designed to be representative of fire started by a cigarette ignition of upholstered furniture in one of the principal occupied rooms of the dwelling. Okay, those are probably 2 common types of scenarios. Another scenario is what they call a high challenge. And this shall be designed to be representative of a free-burning fire in ordinary combustibles, but it will be placed in a dwelling in an egress way or an entryway to a dwelling and have a fairly high rate of heat release. And having said all that, okay, well, how the heck are we going to demonstrate that? The calculation methods used to assess this have to be generally accepted principles of engineering. And now when determining whether a sprinkler system meets the primary performance objectives, its performance shall be assessed relative to each performance objective, and the assessment shall be conducted through the use of appropriate calculation and test methods. That's what some of this technology that I just showed you and some of those methods is going to be used to support this. If we didn't have the engineering calculation methods, and that's why I wanted to show you a little bit of that, we can't do this stuff. Okay? They don't put the scenario in here, what happens if the sprinkler system fails? Which is known to happen, even though the track record is outstanding. And that's probably the weak link of these types of performance-based analysis, where you have failure. We don't know over the life of a building how reliable that sprinkler system might be. Yeah, we've got some good data, but really do we know over the life of a building how reliable it will be, the sprinkler system? We have a real big problem with smoke detection and alarm systems. In talking with some of the gurus who've been writing this for in that arena, we don't have a lot of long-term data on some of those types of systems. And if you're going to trade off some of the bricks and mortar, the passive protection for some of this active stuff, you got to be able to feel confident that your system is going to be reliable. And one cynic just said, well, gee, why don't we just throw out all this performance-based codes and just sprinkler everything? Well, why not? We probably reduce the fire problem substantially. It won't cure it, but the numbers would go down. You know, I mean, that's what a lot of people are saying, because a lot of the same conclusions come down to sprinkler protection. But there's going to be situations that you can't put sprinklers in the building. You may not have the water supply, or you may have an unreliable water supply. You know, there's not going to be situations where that is always going to be appropriate. Are there any questions so far? Have I lost you totally? You're not sleeping yet, but you're getting close. So I know I'm looking at my clock here and going, 8 o'clock. Steve?
Yeah, what's your answer to this age-old nagging question that AHJs have when we have to continue to inspect these buildings? We don't know what they're supposed to be like or maintained as. You know, now we have codes that say this building should conform to this code. But with performance-based codes, how do we know 10 years from now what the occupancy of this room was expected or designed to be and that kind of thing? So what's your answer to that question?
Yeah, and that is one of the Achilles heel again to this process. You have to have, if you design a building to a performance-based approach, there are some very critical assumptions in there. And if you change, the best analogy I can say, if you have a change in use now in a building, when we have a change in use, generally that, from a code standpoint, generally that's triggering that there's a different risk level. I'm not so much worried, for example, if I have an office environment and I'm just going to change the office environment, maybe a tenant build out or something. But if I change that office environment to, let's say, in an office building that's also going to be housing some medical gases or some flammable liquids that exceed the exempt amounts, that changes that complexion of that building. Okay. In sound performance-based design, you should be able to take into a certain range, but what we look at is if you change the inherent characteristic of the occupancy so that it would be defined as what I call a change in use by code, then we've triggered a whole reevaluation of that system. The problem we have is the documentation trail. I mean, if you look at a building that was designed for this 10, 15 years ago, the players have changed, the documents may not have been kept. We have that problem today. I mean, how many of you guys go out and do a retrofit of a building and a tenant build-out and ask for existing sprinkler plans, and unless you did the building or kept a record, some maintenance guy, who knows where they are. It's the same type of challenge, Steve. So there's not a simple answer. One of the best frameworks, by the way, that I saw that deem whether it's a change of use is the Uniform Conservation Code that's written by ICBO. It actually has a general framework in there that can help tell you when you've triggered a change in the risk. If you do this, for example, in a high-pile storage warehouse, and you change the racking configuration, or you change the commodity class, that again would trigger very closely looking at, did this affect the performance approach? Again, the weak link is, do we know how that building was originally designed? And I think we have that problem even today, whether we do it prescriptively. I mean, we go into a lot of warehouses that, you know, the buildings have 25-foot clear height, and somebody put in a light hazard sprinkler system 20 years ago, now they're storing to the rafters. Well, somebody caught that through an inspection process. He said, no, I can't have light hazard in your storing group A plastics. I see that problem here today.
You have it today, but clearly you're going to have it a lot more in the future. This kind of design.
Right, it'll exacerbate the problem. And one of the other things that it'll make more challenging to the AHJ is that if you look at those calculations, and you start looking at a series of calculations, whether they were done by hand or a computer model, as one AHJ said to me who in Minneapolis, who heads up the building department, he said, you know, Mike, this is like structural engineering. A lot of us understand some of the underlying principles, but we don't necessarily have a very in-depth understanding of what these calculations mean and how they're totally interrelated. So it's just like structural engineering. I remember because it was one of the first HVAC designs that we did in that city, and he had made that comment to us. So some of the AHJs are going to be challenged to understand what are these things saying to us? What does this really mean? And do we buy into their assumptions? I mean, so there's a lot there that's a challenge. Bob?
Yeah, the ICC approach right now to the performance code in the committee, they're addressing that, Steve, and one of the best analogies that I came up with out of that one meeting was, they said right now we're using one document, one code book, whatever part of the United States you're in, to look at the building all the same. All the M's are the same, all the A's are the same, you know, within the classification. He said that's not truly correct either. What we end up doing is, like in sprinkler systems, when they do a design base of 13, they basically double it to give it 100% reliability factor on that bottom line test. So what they said is we got to think of it differently. We have to now have the authorities not picking up a code book, but picking up the building file. And that building has to live under that file. And when we modify the building, the file gets changed. So you'll have more information on that building based on what the building should perform to using that approach rather than taking a generic book that someone wrote with a big picture in mind and trying to make that work. And that's right now their theory on how it's going to work. Not that that's the answer.
No, you know, for example, I'll take a building, it's not in this state. This is a facility we consulted on for Nike. It was under the standard building code, which is down in the southern part of the United States. We did it in Tennessee, and everyone in Memphis talks like Elvis, you know. They do. Anyway, this was a facility that by code you couldn't build it. It was an S1 occupancy, storage occupancy, with 3 levels. It was over, what, 300,000 square feet plus? It was huge. Okay? It was very large. And the building official said, there's no way in God's creation you're going to be able to build this thing. There's no code in the land. It also had production lines and racks impeding egress routes. And on the third level, they had 300 people and 15% of them were in wheelchairs. The building official said, if you can demonstrate to me through a performance analysis that you can protect this, we'll consider it. And we'll take it to our Board of Appeals as an alternate method. And interestingly enough, through the discussion, because, and this is just showing part of one scenario, building official said, you know, I really like ESFR sprinklers. He says, can you demonstrate to me if I put ESFR sprinklers under each one of these levels here, and these aren't very tall levels, by the way, you know, it's 18 feet from here to here. Says, I like ESFR sprinklers. I think they'll put out a fire. So if I had a fire in a variety of scenarios down in this area of your storage, I think it's going to control it or put it out. And he said, I've read the data on ESFR, and I think if I put them here, I know I got a little overkill. Okay? Up at the ceiling, we had standard sprinklers, and over in another area, we had ESFR. So it was a combination of systems. And we had to deal with, in this scenario, well, if we had a fire down through here, if it passed through some openings, what happens if it spills, and we have a balcony spill plume, as it's called in the calculations. But we looked at a variety of scenarios, how tenable the space was going to be, and we had to calculate sprinkler response times under a variety of scenarios. And then we had to see whether or not, because we had to define egress routes and calculate egress time, we had to figure out, can we get the people out and protect them, given the type of sprinkler protection that we're going to put in this building, and given how long it would take to move them to a safe refuge. So you had to calculate egress times. You had to calculate the fire size and tenability of the space and plot it over time and see if you had a reasonable cushion. Now, going back 15 years from now, if they do some significant modifications, that could challenge the whole approach. But one of the things that was done in this particular case is try to handle a variety of scenarios. The question being, if someone took this over and totally changed it out, you have to start from scratch. However, is that going to probably be done? It could go either way. But there was no way in the land under a prescriptive code you could build this. But they said, let's look at it under a prescriptive or a performance-based approach. One, just like the language that I mentioned from 13D, can we prevent flashover? Can we keep the space tenable? Can we keep the temperatures down to a certain minimum? Can we safely get the people out? And that's how we looked at the whole fire protection scheme for a building that otherwise would never be allowed to be built under the code.
Mike,
Yeah.
how about the safety factor? What factors did you consider?
Probably a factor of 3.
Okay,
3 times.
so 3 times the exhaust system, 3 times the sprinklers, is that
Yeah.
what it is?
Yeah.
Does that take care of something like, say, a skip that may be caused by such warehousing or blocking the sprinklers so that it would not perform like it was designed to, or over an area that was also supposed to encompass?
On obstruction, you mean?
Right.
Yeah. It takes that into account. But if someone's going to go out and try to defeat the sprinkler system, it throws off your analysis. There's no doubt about it. I mean, whether this was done by a prescriptive code or performance-based, if you don't comply, I mean, the sprinkler system was designed per NFPA standard after. All it was placed. But if someone goes out and puts obstructions in or changes the commodity classes that would not be appropriate for the system, all bets are off. You're vulnerable.
But prescriptive may do the same thing, but then they say, okay, we'll go one step further, we'll go to a compartmentalization
Right.
system, which this one would be eliminating.
Right.
So they'd have a redundant backup should that occur, and that would not be the case in something like this.
In something like this, the compartmentalization was from the next building. We had MFL walls between, because this whole complex was like 600 plus thousand square feet. So we had an MFL wall between this facility and the next adjacent, and the adjoining compartment. So yes, we left the whole thing wide open. Okay. If the sprinkler system fails, we're taking out that space and we've got a multiple loss. So we had to feel very comfortable with the water supply and the reliability of that system. Fortunately, we had very good water out there, which was very predictable and stable over a long period of time. So yeah, I mean, that's one of the challenges of a performance-based approach. You're taking out certain redundancies or belt and suspenders that we've had historically in the code. And the question that always comes up, is that right? Is that something we should be doing? I mean, on the other side of the coin, a study was done up in Canada of the life of apartment buildings and said the most effective thing that you can do to protect people in a building from fire over the life of the building, anybody want to tell me what it was? Somebody said smoke detector. Somebody said sprinkler. Those are wrong. No. Shut the door. Keeping the doors closed. And that was a study done by the National Research Council of Canada, so they came back and said, well, all these people who tout smoke detectors and fire alarm systems, that's fine and good, but this one particular study challenged that paradigm and said, hey, we're showing if you just keep your door shut, that would probably be the greatest cost-effective thing over the life of the building. And it doesn't happen. Doesn't happen. Exactly. I mean, the other thing that nobody's brought up yet is liability. That's probably one of the biggest impediments to the acceptance of this in the United States. At a symposium up in Ottawa last year, they had a gentleman who spearheaded this from Australia, and he said, thank God we don't have the lawyers you have here in the United States. You know, he said, we were able to get this through because we had collaborative effort of the building officials, the fire officials, the design community, but most importantly, we didn't have the legal infrastructure that you have here in the United States. So when you look at a performance-based approach, the liability, it still gets spread to several people. The architect of record, the engineers who have written off this design, whether it be us or someone else, whether it be the mechanical, electrical, whomever has signed off on that design is part of that liability chain. The owner could be even liable. If there were a fire at that facility and there was a failure of that performance-based system, there's a lot of liability out there. And that is probably the greatest obstacle to the acceptance of this type of an approach.
You have no practice.
Oh yeah. Oh yeah.
So how much is the city liable? We accept your design.
I'm not a legal scholar on that, but you guys come away pretty clean, John.
I think the max is 600,000.
Tom?
I think that's an excellent question. There is a tort claim limit I think it's raised to $1 million. But there is cost to defend, and you may be, the authority having jurisdiction may, quote, win, but the cost of winning may be tantamount too. So I'm struck with the fact that if the person comes in and says, look, this is an equivalent, there is a provision that allows the authority having jurisdiction, if they cannot evaluate that, to cause it to be evaluated in, quote, objective third party that can run through the analysis. But it's a little bit like, the analogy I guess I'm trying to get at is if you read some of the current automobile magazines, and they talk about these high-performance automobiles, and there's a certain level of risk associated with it, and you're kind of if you don't embrace this automobile or this this technology or somehow denigrated as not very imaginative, not very creative, not very forward-looking, or whatever. Put whatever adjectives you want to. But I think we're seeing this evolution, and I guess the question to you, Michael, is that are we, for want of a better term, are we stampeding some local, and we can say some state as well, authorities having jurisdiction into kind of not wanting to appear ignorant or behind the times or whatever by presenting this technology?
Yeah, I think that there's some pressure on some people not to feel that they're up to par with some of this emerging technology. I would even say there's a lot of engineers who aren't up on a lot of this technology. The challenge is going to have to be a significant retraining of engineers and authorities having jurisdiction just to accommodate this, to see if they're making a rational decision. And I think you make one good point about one of the things that a lot of these countries have instituted is the independent third-party peer review. And that has been placed into the process so that if the authority having jurisdiction is uncomfortable or is not certain, that they will go to an independent third party to get a peer review consultation. I've not seen that used extensively here, but it has been abroad, and that is part of the protocol that I think will become more commonplace here, because these are revolutionary concepts. And when you think of traditional fire mitigation strategies, I do know that several AHJs do not want to appear ignorant of the technology. On the other hand, I think the ones that may not understand what is all driving it, they can understand the intuitive nature. I mean, a lot of this can go back a certain amount of intuition. We know that sprinkler systems in general have a high probability of preventing flashover. We know if they're designed in accordance, we're not deviating from the how-to standard. We're just applying it in a different manner where we may have taken out a redundancy, such as a rated wall. They'll understand if it's designed to that standard, we know it's going to control the fire to a certain extent. We're just showing them tools that now we're able to approximate that. Yeah, sprinklers work according to how they're designed for the standard. We will eventually produce less smoke, for example. And subsequently, we can reduce some of the requirements for smoke exhaust. And that's where I think that some of them still feel very comfortable, because if you reference it back to the standards, NFPA 13, 72, whatever it may be, they can feel a little more comfortable. But I think that is a definite need for the third-party review to help, because a lot of cities don't have the luxury, such as, like, well, I shouldn't say luxury, but Steve in St. Paul has Chris, who has and Chris didn't bring any of his brochures tonight, but the city of St. Paul will evaluate computer models and other, is that a plug? Do I get 10%? Yeah. 5 today? Okay. But no, in all seriousness, some cities like St. Paul are very forward-thinking, not that I'm going to stroke him today, but it is forward-thinking and unusual. It's not the norm that they have someone. When I sit down, for example, with a Chris Cahill, and again, it's not to flatter him, the discussion level is entirely different than some other jurisdictions. I mean, we can have a very sophisticated technical discussion on the performance aspects of the fire physics here. That's not going to be the case in most jurisdictions. But one of the things that should come up, a third-party review would be very helpful. The other thing I want to mention, when you do all this stuff, is the translation of this stuff to the construction documents. That is, it's nice to put it all on paper, but how do we transmit this to a specification and a design parameters that the sprinkler guys and the fire alarm people and the architect can all understand and execute? And that's where this falls down a lot of times. That communication channel. I find it more and more so that if we don't have an effective communication stream, then it's going to get installed wrong in the field. It's not going to meet the intent of the performance-based approach. And so, in reality, when you've taken it from all these nice numbers on a piece of paper and say, oh, gee, that looks pretty and that looks good, and an engineer's gone through his own, analysis and built a testimonial to himself and a nice bound report, the translation to the construction documents and field execution is critical. And a lot of times, that's where it can fall down. I don't know if I answered your question totally. Yeah?
In the case of residential construction, isn't the performance-based scenario going to add cost to it ultimately?
In what form, for example?
Well, if you're adding all the necessary calculations and so forth, that would have to be done by an engineer. That's going to add a lot of cost to it.
Probably, in a one or two family dwelling, yeah, I think so. But as far as in a lot of other stuff, no. I don't see that.
So it would be more fruitful for apartment buildings.
Larger, yeah. In reality, where's this stuff going to be used? Probably more in higher upscale types of stuff. I mean, that's bottom line. I mean, you're not going to do it for a strip mall. You know, and the codes, by the way, I'm not going to tell you that the prescriptive code's not going away. You're just going to have the option to look at it from a performance-based approach. So you're going to have the choice. They're not going to sit there and say, no, you have to use a performance-based approach. And exactly, on a one or two family dwelling, there's no way in creation you want to use it. The reason I use that as an example, it was an easy target. I mean, that NFPA took that as an easy example, saying if you had to use it. The language that I used in there, and the framework, is the same that's being applied across, whether it's Life Safety Code, NFPA 72, some of the marine shipping codes now are going to be following that. But you're going to have an option still. They're still going to give the designer and the authority having jurisdiction to use the prescriptive codes. And what have they found over in Australia and some of the other countries? Probably 5% of all buildings are done this way. Still 90-95% are done good old-fashioned way. That number may creep up, but it's not going to become the standard operating practice, but it will be used quite a bit on larger projects.
Using the performance base, is it theoretically possible to go to an unrestricted fire area?
What are you driving at?
Well, instead of limiting the fire area to 100,000 or 200,000 square feet,
sure.
why not go up to 500,000 square feet into a single fire area?
It possibly could, but I'm not saying that might be the prudent. A risk analysis might not prove that. I mean, it depends on what you're talking about. If you've got something with incredibly high value per square foot, I mean, we had a 1 million square foot warehouse out west. The building, I think, cost $20 million. The contents in there were $280 million. We still put in a certain amount of redundancy, compartmentalization in that type of facility. Rather than leaving it wide open, you have to evaluate a lot of variables, and I think it would be, it's not prudent to do that. On the other hand, though, just because, I'm going to throw at you, just because the building code, after you go through all your gyrations, and it says you can only build this building 50,000 square feet, what in there says that if I want to build it 55,000 square feet or 60,000 square feet, that's ridiculous? I mean, or that's really unsafe? Or if I have a travel distance of 400 feet, is it that more unsafe if I want it to be 500 square feet or 425 square feet? I mean, those are some of the questions you can ask, but it's not a generic answer. It has to really be applied to what you've got in the building. I couldn't come out with carte blanche and say, no, we're going to have just unlimited areas. No. It really comes down to what you have for a risk. If I had a very low hazard environment, low fuel load, if I was storing rolls of steel, sure, why can't I have unlimited area if I'm just storing rolls of steel? But if I'm storing Group A plastics, I don't think I'm going to take it that far. As an extreme example. I mean, there's a lot. Yeah, Tom.
We were reminiscing a little bit about the history of this association and different meeting places, and I can remember one night at a different location talking with Rolf Jensen, how we were quizzing him, or the table conversation was quizzing him about how did he arrive with A and B and C, some of these tables. And he's talking about, well, we took the best minds of the time, we set them in a room, and we made our best guess. And we were remarkably close on some, but we were way off on others. And I'm speaking deliberately, very generally. And yet, going back to the prescriptive code, we have relied heavily on what was considered the finest thinking at the time. Goes back to your presentation, if you can trace back to the basic assumptions, and that's appropriate. I worry sometimes about, are some of the basic assumptions flawed? How did we arrive at, for instance, what an appropriate dead-end corridor length was? And the answer is, the average man, obviously not politically correct, the average person could hold their breath for about that length of time.
Yep.
I mean, that's the scientific analysis that went into it. And so what I worry about, that maybe, and maybe this is a plus, this approach may force a reevaluation of some of the original theorems, axioms, whatever you want to call it, and go back historically and see, if some of these basic requirements, what is the validity? And I dare say that the length of time someone can hold their breath is may well be one indice, but I think we can certainly approach it a little more refinement than that.
And I think that's a real good point, because we can challenge some of our underlying assumptions. And even on the other, I think we find in some cases, we might be, some of the requirements may be restrictive. On the other hand, we might find we're underprotected in some other types of occupancies on the other side of the coin. And I think that's part of what this technology brings us, information, and it's all how we use that information. I'll tell you one area that I would be very reluctant to use a performance-based analysis in its purest sense, and that's flammable and combustible liquid storage. I don't think I'd tamper a lot with NFPA 30 or Article 79 and 80 of the Fire Code, because I don't think the body of knowledge is there enough to know what we're dealing with. I really don't. So I think that you have to pick and choose very carefully where you can use this, and generally speaking, it's not in those way high-end hazards such as an H occupancy. You may use it in a high-tech environment that may not have the same type of potential as flammable or combustible liquids, but I would be very cautious to do that.
I just wanted to make a comment, Mike. It seems to me that, for instance, if we're talking about the residential design that's in the code itself is getting to be very close to be a performance-based spec, because you're not going to put in anything else but that residential sprinkler, which incorporates all those requirements.
Right.
So the cookie-cutter approach basically works as long as the engineering fundamentals are part of that discussion in the code itself.
Right.
And some of that has come a long way. The other comment I would like to make is that it sounds to me now that there is the NFPA 25, that code is going to take on much added importance now that you have to maintain this requirement within this building.
That's an excellent point. Maintainability of these systems is going to become far more pivotal, far more, and particularly as we put in more of these active systems. And yes, we're not going to deviate from the standards. It's just how they're applying them. And yet, intuitively, again, you're going to be meeting a lot of this criteria right out of the starting gate. Any other questions? Gordy?
Is anybody looking at how people react to fires? And you touched on that, about the length of dead end exits and things like that. We've got a lot of numbers for how fast fires grow and how quickly sprinklers react, but how do people react?
There's been a lot of studies. Probably the most current body of knowledge you can find in the NFPA handbook, the most recent edition with the 18th, 19th edition. I think there's still a lot unknown about human behavior, but they do know that people work off of social cues, okay? And they're going to react over how they perceive the risk. That is still a certain amount of unknown. We do a timed exiting study, and we say, oh, it's going to take us 20 minutes to evacuate this high-rise building. Guess what I say? I look at that number and say, okay, it might take 20 minutes, but guess what? It tells me I can't evacuate this building in a time that I need to. So what do? I put in a very aggressive sprinkler system to minimize that impact. That might go to quick response. The same in these arenas. I mean, we're going to do these calculations, and go through all that exercise, but in reality, we know that people are going to react over with different social cues depending upon the risk that they perceive. There's a lot of unknowns there. All we can do is work off of what we think is our best estimate and put as much as we can into the active systems and the fixed in place protection so that we can minimize the size of that risk. So if I go out, and that's one of the reasons I like to advocate quick response sprinklers. Why? It helps me with a lot of tangible benefits. I know if I can keep the fire small enough, it'll help me reduce some of those other things that could happen, such as the unpredictability of people. If they see that a fire is controlled, they may not go into a panic mode. They very well still could. But I know if we keep it smaller, we'll partially minimize that. It's probably the most unknown thing. It's like any other element of human behavior. There's a lot of data out there. Jake Pauls did a lot of studies of the Montreal Olympics. We still use a fair amount of that to help people move. But under emergency conditions, you hear the stories across the lot. Oh yes, these people, even in the tremendous fire pit, evacuated orderly. And then we see them in other instances where it seemed relatively minor that they went into a panic mode. And a lot of it goes off of social cues. They once did a study where they put people in a room. And they started the room, they had I forgot what percentage were actual, the people they were studying. They put in a bunch of actors. And they had them sitting in the room with these other people, and they didn't know. But all of a sudden they're sitting in this room, and the room starts filling up with smoke. And the actors just sat there cool, calm, and collected as this room started filling up totally with smoke. And the specimens they were observing looked around to see what everyone else was doing, and most of the people in there were, hey, there's no problem, you know, this place is getting fairly thick with smoke. And they didn't move. And then on the other hand, they did flipped it around, very little in there, and somebody gets up and, we gotta get out of here. And they said a lot of the people reacted to those other social cues. So it's probably one of those things that, you know, we have the least amount of data on. We know we can calculate it very efficiently, like a hydraulic equation. The question is figuring out if they go into panic mode. And the way I look at it is that if we can put enough aggressive fixed in place protection to minimize the overall fire threat of getting out of hand, it helps us. I don't have a scientific study, it's just my opinion that if I keep the fire small, keep it to a non-threatening level, which I would define as a relatively small fire, maybe under 500 kilowatts, and in a given environment, maybe that's all I need. But you're right, there's not a lot there. Tom?
You might look, Gordy, at what some of the airline industry studies have been in terms of people evacuated. And I think you're right, you're correct. In the height of some of the worst life-threatening situations, people are still taking time to get their luggage out over the overhead. And somebody still saves their bottle of scotch and proceeds to drop it, and it breaks on the ramp, the chute getting out of the airplane, causing even more damage. But if someone at the height of a life-threatening situation is going to save a bottle of scotch, I mean, obviously there's some education, if not other solutions for that issue.
I think in our design, because people are so unpredictable, I try to look at it from the standpoint, let's try to take as much of that human element out as possible. That's why I like aggressive fire protection systems, because I can't go out and predict what people will do. I can give you certain numbers, but bottom line is I got to look at what do I think I've got here to keep that fire at a size that I think will minimize the overall risk. All right. Paul, did you have a question?
No, I guess the only comment I was going to make earlier was that it was there's a certain amount of leap of faith in some of these going to performance-based codes, because the codes are only as good as on what they are based. You know, the criteria on what they're based, and a lot of the testing that's been done, it's out there, and the models that are being used are, you know, they are based on that testing. If that is somehow flawed, we do have a problem.
I mean, that's a big, Paul hit a very critical point, another Achilles heel. If the test methods, if they're flawed, can undermine this, and this was one of the other Achilles heel they talked about. I'll use an example that's very common today, interior finish requirements. We can go out and have a Class A flame spread rating on a material, which can be used in just about anywhere, okay, egress routes, etc. Well, the way they test that material generally is in what's called the Steiner tunnel test. And it's a horizontal test of flame spread and smoke development. Okay? Test in the horizontal position. When you take that test method and you turn it into vertical position, that same material that could have a Class A flame spread rating, you could increase the flame spread by over a factor of 50. But yet it's not addressed in the standard, and it's codified in code. So one of the things you have to look at are our standards that we're using to evaluate, list, approve these systems. Are they solid? The cone calorimeter test for the rates of heat release, are they going to be accurate enough? I mean, those are the things we constantly have to scrutinize. So between reliability and the credibility of the test procedures, that could be the thing that could undermine some of this. So we're constantly evaluating them. I'll take one more question and wrap up. Yeah.
How is the insurance industry reacting so far as things?
Did you see anything, Bob? Or guys,
Don't see very much of it. Probably more in the arenas, the hotels with the 20-foot or 20-story open atrium. How we react with it, same way you might. It's, how well do you know the calculations? How well do you trust the calculations? The reliability of the system 2, 5, 10 years out from when it was installed. A lot of concerns.
I'll tell you probably the closest I have where the insurance company has been made sure up front. Bob hit a good point. We do a fair amount of gaming casinos. We're granted their sovereign nation. However, the finance people who fund these things, there's a lot of risk management going into these things. So they're the closest thing to an authority having jurisdiction. Not on all, but on many of them. They've reacted in certain terms very favorably. But they do question, again, do we trust what the numbers are? Do we have reliable systems? Will these people maintain this stuff? I think the jury's still out, quite frankly. This stuff's still in its infancy, even though it's out there quite a bit. We still have an awfully long way to go. Tonight I just wanted to give you a glimpse of where some of these things are headed. And you might like it, you might not like it, and, but it's like the old, no, it's not that bad. I was going to mention an old Little Rascals thing, and Steiner talking to Spanky once. They were in one of those little go-karts that was out of control and they're going down the hill. Steiner says to Spanky, he says, "Where are we going?" He says, "I don't know, but we're on our way." You know, that kind of thing. So, just to wrap up, there is a code equivalency section in the code that does tell you that, as I mentioned in my opening comments, that the provisions of the code, prescriptive code, are not intended to prevent the use of any material or alternate design. The catch-all is, you got to prove it. And do we feel comfortable with the proof that we have if we look at these today? Because this is how these performance-based approaches are being accepted today. And with that, I'll call it a night, but if you want any more information, I do have an article that we printed from the Construction Specifier magazine from a couple of years ago that kind of highlights some of these things. If you'd like a copy, I've got a bunch of them here, and if we run out, get one from the office. So again, thank you. There's just a quick glimpse of the future, and hopefully either we helped clarify a few things, confused you, or he's not sleeping yet, but he's close. So thank you very much, and good night.